Hi, I'm Avery Ash, and tonight we are taking a look at this big old project we've been working on this term. All of these different systems are connected together in our bodies to create all kinds of good stuff. And tonight we are focusing on the pieces that will create our DNA and RNA. So we're gonna head on over, take a look at glucose here. And glucose is going to undergo the glycolysis pathway here, get us down to pyruvate. The pyruvate here is going to enter into the pyruvate dehydrogenase complex. And through this process, it's going to create acetyl-CoA, and it's going to produce CO2, and it's also going to produce NADH. We're going to save the CO2 for later, but the acetyl-CoA and the NADH are going to enter into the citric acid cycle, and it's going to go through a few rounds of the citric acid cycle here. We're going to get some more NADH, some more CO2. We're also going to produce ATP and FADH2. That FADH2 and NADH is going to come over here, enter into the electron transport chain. It's going to create a hydrogen gradient, which is going to produce a whole bunch of ATP. Now we got all this ATP, all this energy. We're going to go back over to glycolysis and glucose, but we're not going to get too far in glycolysis. We're just going to make a bunch of glucose 6-phosphate, because this stuff we're going to use up here in the pentose phosphate pathway. So we're going to get two important things out of this pathway. The first is going to be the ribose 5-phosphate. This is going to create the backbone of our DNA and RNA. So this is the good stuff. Some of this ribose 5-phosphate will become PRPP, which is the second, important thing that we're going to get from this pathway. The PRPP is what we're going to use to make our nucleotide. So we're going to slide over here. So PRPP we're going to use to make our purines. It's going to undergo this pathway here until we get inosinate, which will then go down two different pathways, and we're either going to end up with adenine or guanine. But we got our purines made here. To get our pyrimidines, we're going to go back to that CO2 that we made earlier right here. So the CO2 is going to undergo pathway here, going to make us some iridolite, and the iridolite then can split into two different pathways and bring us some uracil, some cytosine, or some thymine. And that is how we get all of the basic components that make up our DNA, our RNA, our genetic code. It all comes together very beautifully. And yeah, it's been fun. Hope you have a good night.